Hi, my name is Mike Moore. I'm a Technical Architect Director with MuleSoft's Customer Success Strategy and Architecture team. Today, organizations are increasingly focusing on API security. They're looking for ways to move away from using named credentials and towards using token-based authorization mechanisms. Today, we'll look at what industry standard frameworks are being used in API security and how you can integrate your identity and access management system to the Anypoint Platform. We'll also do a walkthrough of how to incorporate OAuth into your existing API implementations. So let's get started. Okay, so first thing that we're going to cover are some basics around OAuth and OpenID dynamic client registration. Then we'll get into an actual walkthrough where we set up Octo as an OIDC provider and configure it in the Anypoint platform. We'll add OIDC access token validation to an existing API proxy, and then demonstrate how dynamic client registration works so that when a client application is created in the Anypoint platform, it is also created inside of Octo. Then we'll demonstrate how authorization code grant types work when controlling access to an API. First, let's look at the basics of OAuth and OpenID Connect. OAuth is a delegated authorization framework that is generic by design. The contents and the structure of the tokens are undefined, and it does not define how to perform authentication. This allows it to be flexible and usable across many different use cases and by different organizations. For API security, OAuth is used to grant access of an API or resource to a client application via the permissions that are granted by a third-party identity provider. OpenID Connect, or OIDC, on the other hand, has a strict definition of the tokens and authentication flows and is used to extend OAuth 2. It also adds dynamic client registration, which allows other systems to register clients within the IDP. In our case, API Manager and Exchange are used. So let's take a look at the OIDC standards. The most important for the Anypoint platform is the well-known OpenID configuration. This is the single source of truth for how the platform is going to interact with the provider. It provides all the details on the endpoints necessary to interact with the identity provider, the grant types, which are how our client application will be authorized and obtain an access token, and the supported scopes, which is typically what the app can do or the data that it can access. Also, it will have the claims, which are attributes about the user the client application is representing. And these can be used to drive data filtering or other logic inside of the API implementation. There are several different grant types, but for API security, we typically focus on two. Authorization code, which is used when a client app is going to act on resources with user context. And this mode allows a user to authenticate and authorize the client directly against the identity provider so that the client application does not actually receive the user's credentials. Client credentials are used for interactions without a user context. This is typically used for system-to-system or API-to-API calls. So let's get into our walkthrough. For this walkthrough, we have the identity provider and store, which is going to be Octo. Keep in mind, we're not necessarily going to go into depth on how to set up Octo, and if you use a different identity provider, the overall process is the same, as the Anypoint platform uses industry standards like OIDC to interact with the identity provider. Be sure to consult your identity provider's documentation and support for assistance in configuring this portion. For simplicity's sake, I'll use Postman as the client app. This would normally be a mobile app, web app, or other API consumer. The resource in this case will be a Mule proxy that's secured by API Manager for searching for flights for a travel portal. After everything is configured, the OAuth authorization code dance will look something like this. The app will direct the user to the identity provider to authenticate and authorize the client application. Once authorized, the IDP will send the client app an authorization code on the callback URL that was configured when the client app was registered. The client app will exchange this code for an access token associated with the user context. The app will call the API with the access token in the authorization header. The OIDC token validation policy will call the introspection endpoint inside of Octo and confirm that the token is valid, aligns with the configured scopes, and that the client ID that obtained the token is permitted to call the API. If all of this is successful, the data will be returned. So now let's take a look at how all of this is set up. Okay, here we are in Octo, and this is a developer preview version of Octo. We're going to navigate to API and then authorization servers. Octo can support multiple authorization servers, and you can customize this, but for simplicity's sake, we're going to use the default authorization server that Octo provides. We're going to navigate to API and tokens and create our single-use access token. This is the token that's going to be used by the platform when registering new clients in the OpenID client ID registration. Make note of this token value because it will not be shown to you again. At this point, we're going to navigate to Applications, and we're going to set up the Anypoint Platform as a client application to Okta. Go to Service and give the client application a name. Be sure to make note of these values as well. The client ID and secret here will be used for the API Manager policy validation to interact with Okta to validate incoming access token requests. Now, I mentioned that each OIDC endpoint has a well-known OpenID configuration document, and here's ours for Okta. You can see that this references my development environment and the default authorization server. So let's take a look at what's inside of this document. So the well-known configuration has our issuer. It has the authorization endpoint, the token endpoint, the registration endpoint, the grant types that are supported, and if you scroll down, we also have the introspection endpoint, and this is how the token validation will occur within the policy. Scrolling back up, it's important to make note of the grant type supported. This is controlled by the identity provider, and this determines the UI options that will be presented to a user when they're requesting access for their client application. So now let's go into the Anypoint Platform and add in a client provider. We're going to select an OpenID Connect provider and give it a name. Now we're going to copy and paste the values that we saw in the well-known configuration into the Anypoint Platform. We'll start with the issuer. The registration endpoint. We'll set our authorization header, and for Okta this is prefixed with SSWS, and then that initial access token that we were presented with when we were setting up Okta. We'll need to paste in the client ID and secret. And then the last three URIs that were required for authorization, for token, and introspection. Once we have all this pasted in, we can hit create. Our next step is optional depending on how many identity providers that you have. If you only have one, that provider will be set automatically as the default. In this case, I have multiple, so I need to go in and associate this with specific environments and set it as the default. You'll see a prompt that this only affects new APIs, which means that if you have existing APIs with existing identity providers, those will not be affected. So the next thing that we need to do is go into Design Center and update our API specification for the Travel Portal API. So let's log in to Design Center and take a look at the Travel Portal API. We can see that the Travel Portal API doesn't yet have a security scheme defined. So let's go into Exchange and see if there's one that we can add. I've already created an Okta security scheme fragment that we can use for this API. So we'll select that and add it as a dependency. Now that it's been added to the project, we can take a look at what's inside the fragment. You can see that the OAuth security scheme includes information about the authorization header required, the potential responses, the authorization URI, access token URI, and grant type supported. So let's go into our main REML definition and add the security scheme to our API. First, we'll add in the security scheme itself and define that. I'm going to give it a name of OAuth 2, and we're going to include the fragment. We can copy the path and paste it in. From here, we're going to designate that the entire API definition is secured by this security scheme. And if we look at the API console along the right, we can now see that our API documentation references the appropriate security scheme that we're going to apply to this API. So from here, we can publish the new version out to Exchange. Once we have this published to Exchange, we can update our API Manager definition to reference the new version of the API specification. So let's navigate to API Manager. We'll select the Travel Portal Flight Search. And under Actions, we'll change the API definition to our current version that has the OAuth security scheme applied. Okay, while that's applying, we can go and also set up the OpenID Connect Access Token Enforcement policy. So let's select the most current version and click Configure Policy. We need to configure a list of scopes that are applicable to the API to control access. I'm going to set up a single scope called Get Flights. You could apply scope to the entire API or to a single resource and method. In the policy, you have the ability to validate that a token contains any scope that's defined in the list, or if it needs to contain all the scopes, depending on your use case. The policy can also validate the TLS certificate that's being presented by the identity provider, so you can have assurance that you're connecting to the right identity provider. Expose headers will take all of the contents of the access token and make them available on the incoming request so that the API implementation could use them for data filtration or other business logic. Keep in mind that this configuration can be applied to the entire API or a subset of resources and methods. This would allow you to configure different scopes for different actions on the API, such as read versus write. So let's go back to Octo, and then we can add in our Get Flights scope. Once we're in Octo, we'll navigate to API and authorization servers. We'll go to the default authorization server and click on Scopes. And from here, we can add in any custom scopes that we want. So we'll type in our scope name and a phrase for the user to understand what permissions the application is requesting on their behalf. We could require user consent for this scope. We could make it a default scope, or also include it in the public metadata in the well-known configuration file that we looked at earlier. So I'll go ahead and create this scope. Now we can navigate back to the Anypoint Platform and continue our setup. Let's go back into the Travel Portal Flight Search API and make sure that this API is associated with our new client provider. So let's switch this to our Octo OIDC provider that we'd set up and hit Save. Now we're ready to register our client application. So we'll go out to Exchange. And we can request access to our Travel Portal Flight Search API. We'll select the sandbox instance, and we'll create a new client application. We're registering a client application that is going to consume this API. We're going to check authorization code grant, and we need to give the redirect URI where the authorization code is going to be sent. In this case, we're using Postman, so we'll use the predefined Postman URL. We can request access from here, and it was approved. Now this client ID and client secret are not generated by the Anypoint Platform, they're actually generated by Octo. When we requested access and created a client application, that information was actually sent over to Octo. So we'll store these values so that we can use them in the subsequent request. Now before we can call this API, we do need to do an additional step inside of Octo. We need to associate this client application that we just created with the user population. Now normally this may be automated, you may have scripts to do this. In our case, we're going to manually assign this client application to my user. So we'll go back to Applications, and we'll select Assignments for the application. And I'll assign it to myself. Now that that's done, we're ready to call the API. So let's navigate over to Postman. And we'll configure our endpoint as if we were calling it as a client application. The first thing that we need to do is build the authorization request. So we'll set the authorization code grant type, pass in our callback URL, our authorization URL, access token URL, the client ID and secret that we just received from the platform, and the desired scope for the client application. State is a client-generated value to ensure that when the authorization code is returned, that the request has not been tampered with. From here, we can submit our request. Now, because I'm already authenticated, it did not challenge me to log in again, and instead issued the access token to the callback URL, and Postman has now been able to obtain it. Now we can use this to make our request. So now that we have our access token, we can click Use It, and it'll paste it in as the authorization header for this request. And we can go ahead and send a request to the backend now. We can see the request was accepted, and we have our response back. Now, if I go and change this token or remove it from the request, when I send a subsequent request, it is going to fail because when checking with Octo, it is not a valid token. So one thing that we can do is actually see what the contents of that access token look like. I'm going to copy the access token and then call Octo's introspection endpoint. And this is the same endpoint that the OIDC access token enforcement policy uses to validate the token is valid. So here we have the results back from the introspection endpoint. And if we look at the contents, we can see that we have a token that's active. We can see the user. We can see the scope that was requested. We can also see the client ID that requested it, as well as other attributes that I've added into the token about the user itself, which could be used to filter data or implement other business logic inside of the API implementation. Hopefully that was a helpful walkthrough of how to incorporate your identity management system into the Anypoint platform and use OAuth to secure your APIs. Thanks for watching.